There are three primary reasons that keep the Earth hot, hot, hot. The top three things that keep the Earth warm are, number 3, accretion, where early particles that were forming the Earth smashed together and kept everything kind of warm. Number 2 is going to be friction. Think about what you do with your hands when it's a little bit cold outside. And number 1 on our list is going to be the atomic reactions that happen in radioactive isotopes releasing heat energy. Number 3 on our hot core countdown is accretion. So, when the early Earth formed, what happened is lots of other particles smashed into each other, and this created a lot of warmth because the early Earth was molten lava everywhere. But it lost energy very quickly to the outside space. Through this accretion, this kind of snowball effect of gathering up more particles, the Earth gained enough heat that it still kind of retains some of that heat even today. So the early Earth is this molten orb, and it starts to cool down, and it forms a crust. Now, this might have only taken a couple of thousand years for the outer parts of the Earth to solidify because of how cold interstellar space really is. This accretionary heat that the Earth has retained has been around a long time. 4.6 billion years! Thank you. Number 2 on our hot core countdown is friction. The friction within our continental crust and our oceanic crust interacting with the mantle. Take your left hand. Now the left hand is going to represent lighter continental crust. It is less dense than oceanic crust, which smashes into the continental crust. And as the oceanic crust crashes into the continental crust, it scrapes under and sinks down into the mantle under the continental crust. And if you do this with your hands, you can feel the heat being generated. Now think about that if it was rocks rubbing together. Fact, as the oceanic crust is carried below the continental crust due to subduction, because the oceanic crust is more dense than the continental crust, it carries water with it. As that water heats up, it turns to steam. And that steam has to go somewhere, so it creates larger volcanoes than we otherwise would have. And that's why we get the Ring of Fire around the Pacific, which is lots and lots of volcanoes being created by the addition of water being added to the rocks that are below continental crust and onwards into the very higher portions of the mantle. More volcanoes. And the winner at keeping the interior of the Earth hot is radioactive decay of elements at number 1. The primary radioactive materials that are inside the Earth keeping it warm are uranium-238, thorium-232, and potassium-40, which is the most important radioactive material that we have in our core because it releases the most energy. These elements release energy as they degrade into lower atomic number elements. This radioactive decay releases energy in the form of heat. And the radioactive decay of elements accounts for over 50% of the internal heat that keeps the internal portions of the Earth warm. This is why geothermal energy works to heat our homes and businesses. You don't have to go down very deeply into the crust to have a stable temperature no matter what time of year it is. We then set up heat pumps to retrieve the energy in the form of heat. The Earth's size makes the radioactive elements a part of what keeps the core hot. If our planet was smaller, like Mars, there may not be enough heat produced by radioactives to keep our mantle moving. Recap. The Earth remains hot because the formation of our solar system gave the core of the Earth and the mantle some energy, and that energy has had a really tough time escaping because our crust traps that energy inside. And as the oceanic crust subducts below the continental crust, we get a lot of friction. And that friction continues as the oceanic crust breaks off and goes down into the mantle. And most importantly, to keeping the interior of the Earth warm, is the decay of radioactive elements, specifically potassium-40. As they decay into lower atomic numbers, they release heat energy and accounts for the majority of the heat energy that helps keep the Earth warm. Time for concept question. Number 1. Identify and explain why the Earth keeps its accretion heat energy from when the Earth formed. Number 2. Demonstrate how you would describe the role of friction in Earth's internal heat. Diagram with stick figures how you would explain this to another person. Number 3. Illustrate a practical way that humans use the same radioactive materials from the core to create usable heat energy.